Have you ever wondered how bats and insects make their way around our busy and bright streets at night? And did you know that there's much more to biodiversity than just making sure that frogs can use our backyard swimming pool? With a laundry list of grand challenges, we are all called upon each and every day to think of out-of-the-box ways to make our world a more sustainable place. This show is about inspiring individuals and their journey along the cutting edges of science, engineering, technology, and design. I'm your host, Peter Marcus Bach, and this is the Grand Challenges podcast. My guest today is Dr. Janine Bolliger, a senior researcher at the Swiss Federal Institute for Forest, Snow and Landscape Research and lecturer at the University of Zurich. Janine tackles challenges in landscape ecology from land use change to biodiversity protection and enhancement, and a deeper understanding of how we can address these in human-dominated landscapes. In today's show, we discuss Janine's work around how light pollution affects non-humans. We also unravel the elements behind the term biodiversity and how we can create more ecological cities in future. For more information, refer to the show notes over at petermbach.com/podcast. Thank you for joining and please enjoy the show. Janine, welcome to the show. It's good to have you here.
Thanks, Peter, for having me here. I'm looking forward.
And you've done a very nice long travel from the other side of Zurich this morning to get here, so really appreciate it.
Yeah, thank you very much.
And looking forward to getting into a topic that we haven't really covered yet on the podcast. It's been sort of hinted at in a few different episodes, but really around this idea of biodiversity.
Yeah.
And hopefully we can shed some light to the listeners on really what it means. And it's more than just animals and plants and how many of them we have. Mm-hmm. Maybe to begin with, what I noticed as you were unpacking your notes is that you're reviewing a paper at the moment, but it seems that rather than reviewing, you're doodling all over the paper and making an artistic piece of work. Is that a strategy you use to, I guess, get your mind thinking about the content?
Yeah, certainly it is. So when I'm in meetings, oftentimes they tend to be a bit boring. So I try to take out my stuff or improve it by just drawing things on it. And that helps me channel my thoughts so I can better listen to the core of things.
I noticed some really, really detailed, complex doodles around it. We'll have to put a picture in the show notes for the listeners, at least of the parts we can show, because this is a paper in review.
It's exactly it. I can't give you that for taking a picture.
Yeah, no worries. But yeah, very interesting strategy. I should try that myself as well. I used to doodle back in high school, but I haven't been doing that as much. I think I try to keep things as neat and clean as possible. Mm-hmm. But I guess it represents one of your quirks. You said to me earlier that you're a very serious person, but I don't really notice that. In the collaborations we've had together, it's always been very relaxed. And somehow you've always been able to see the fun side in a lot of the work we do.
Mm-hmm. Yeah, that's true, because I'm able actually to do what I want. And that, of course, is a great privilege of a scientist who has found a permanent position. And I'm very grateful for this, to be able to develop my thoughts and to develop my ideas and pursue them for a longer period of time.
No, that's certainly true. And I'm excited as well, because I've also just found one permanent position, and it'll be fun to see where life takes me and where the collaboration will take us.
Yeah, I hope it will continue. So I think that's a great chance for you, or for both of us.
No, definitely. And we met in 2020 during the pandemic. Very interesting way that we met, actually. It was online, and it was this they called it an unconference. So conferences, for the listeners, are usually places where academics, industry gather. They listen to different talks and exchange knowledge and network. But they always said that the best ideas or the most impactful collaborations happen in the coffee breaks of conferences. So not when you're listening to the actual ideas, but when you're, I guess, trying to refute or argue or agree with people later on with a nice cup of coffee. Mm-hmm. And in 2020, with the pandemic, not being able to meet, we had attended this unconference. So they deliberately called it because it's meant to be a not conference, but rather networking around the topic of biodiversity. And yeah, we met there by chance, introduced by a mutual contact who also attended, who's also been on the show, actually. And yeah, we just started exchanging ideas. And how many years? Well, 3 years later, we're now here.
Yep. And we have at least 2 funded proposals.
Yeah.
So that's kind of a great success, which I enjoy.
And some recent papers as well that we'll put in the show notes, and we'll definitely get to talking about today. But you gave me that introduction into biodiversity, which, admitting as well to listeners, that I thought of biodiversity always as just simply making sure that we have lots of different plant species and lots of different animal species on the planet, because that's important for sustaining an ecosystem. But actually, it's a lot more than just that.
Yeah, surely there are different levels of biodiversity that we should look at. There is the genetic level, there is the individual species or the individual level. Then there's the population level, the community level, and certainly the ecosystem level. And just by this sort of list of things to look at, you know, how complex things are, because you can't conclude from a genetic assessment to the ecosystem level. So you have to really work on different levels individually before you can get a clear picture of the whole system. And I'm coming from sort of traditional biology, so I studied biology, organismic biology, and I was trying to work in areas where people are not present. So in alpine grasslands, and trying to get rid of the human impact, which of course is difficult. But as my career advanced, I noticed that we can't do without people. So I shifted more towards biology in human-dominated areas. Let's say in grasslands, where we looked at grasshopper genetic diversity. And now, in the last stage of my career, I try to include humans by combining biology and humans in social ecological networks. And just by this complexity, you notice that it's not that easy to say what biodiversity is. Of course, there are indicators, species richness, how they are distributed in an area, how many species there are, the abundance, but also the spatial context. And I think that's the key here. Assessing biodiversity in a spatial context is really a challenge that we tackle and we should tackle.
Yeah, it's fascinating that, in a way, your whole journey has uncovered, to your understanding, really that complexity of biodiversity. And I guess it's something we can get into now and unpack step by step as we progress through. So you mentioned, we know it's not just about the number of plants and animals, but genetic diversity is one particular aspect. And from what I understand, when I was learning it from you in the collaborations we did, it's really the need for animals to be able to exchange genes and to have a diverse pool. That's where the diversity sort of comes in, the word diversity. Because with a diverse genetic exchange, animals become more adaptable to the drivers that may threaten them, such as climate change or just generally, you know, the environmental aspects that are affecting the landscapes that you work in, whether it's human-dominated landscapes like cities or the more forested or alpine landscapes.
Yes, well, we have to make sure that the gene flow, so the movement between individuals across the human-dominated land use is really ensured. Of course, we like connectivity because it offers a way to improve the genetic exchange, to enhance that across the landscapes. But of course, there are also dangers to having increased genetic exchange, for example, with the different pathogens or mutations that spread and shouldn't spread, or, for example, invasive species who have a different setup of genetic composition that then really makes them, they have a fast generation cycle and they spread rather easily compared to, for example, native plants. So there is both sides to it, but still at the moment in human-dominated landscapes, in cities, we try to improve this connectivity by assessing different green spaces, for example, and see how they contribute to a network of green areas in otherwise impervious surroundings.
Yeah.
Genau.
So in a way, plants and animals, diversity of them from a genetic point of view, to ensure that we want to make sure that they can get from habitat to habitat. But when you build a city, that sort of makes that connectivity a lot more difficult. It breaks that.
Yes, that's the hypothesis. In fact, we've been working with grasshoppers in heavily managed grasslands, so not cities, but grasslands. It was roughly 100 square kilometers, and there we didn't find any genetic structure. So in a spatial context, even in human-dominated landscapes, it may be not such a problem for species that are not rare, so that are rather abundant, frequently distributed in the landscape. And also that raises a big issue. What is a population in a spatial context? I mean, if we talk about, we want to sample populations in urban areas, we don't know what we talk about. So the example of the 100 square kilometer grassland and no genetic pattern, so saying that all the species, all the individuals are actually freely exchanging, that really raises questions, rather fundamental questions. What is a population? in a landscape.
So we're even questioning that just the mere definition. I guess for humans, we know this is pretty clear, but I guess these are still things being defined or answered from all the other aspects and for all the other animals as well. Very, very intriguing, very complex, and we'll get back to connectivity as we progress through this. But in a way, you began in biology, ecophysiology and systems ecology.
Exactly.
The Department of Biology in the University of Basel, and then undertook a PhD in landscape modeling. So are we talking about understanding the characteristics of the landscape, or is it more about the dynamics?
Well, I studied, as I said, in traditional biology, and in my master's thesis, I covered an experimental setting with fertilizer in an alpine meadow. And that was a bit limited in my point of view. You know, you just have a couple of sites that you investigate. So I felt what I'm doing is not important in a larger spatial context. So I had the feeling that I need to move up and think a bit bigger in a landscape context or even broader ecosystem context. And that led me to the idea of taking a PhD in modeling. And I was very intrigued by the idea of discovering patterns in the landscape and then explaining them by ecological processes. So patterns of distribution of species, for example, and then try to understand the processes that lead to these patterns. Is it just simply the movement capacity of the species, or is it also the landscape composition and configuration, so the spatial context that drives these patterns? And also, what role might behavior play? Although I never got to analyze this, but the more I work with combinations of models and experiments, I think behavior is the key thing that should really be added more in these spatial analysis. Even of insects, I mean, I'm sure they have a behavior.
No, definitely. And this PhD was undertaken at the University of Bern.
Exactly.
So you went from one end of Switzerland to the center. And spoiler alert, you're now here in the eastern region at the Swiss Federal Institute of Forest, Snow and Landscape Research. But in between that, you actually did a jump to the US briefly, where you undertook your first postdoc at the University of Wisconsin-Madison. And that was, again, expanding your knowledge and your horizons around what you've already been doing.
So after my PhD, I felt like I had to leave Switzerland because Switzerland is a small country and, you know, I just wanted to have something bigger. And then I went to Madison. It was a matter of opportunity, of course, but also a matter of chance. And I also wanted to go to an area where it's not where you want to go as a tourist. So Madison is flat, doesn't have any super special attractions. But it's a great big university, and as I only realized later that most ecologists that I met during my career were one way or another connected to University of Wisconsin-Madison. Either they did a PhD there or their bachelor or they visited or whatnot. So I think it was a great source of inspiration in the lab I was. And I got in touch first time with remote sensing applications there. And although I didn't pursue this path, it helped me a lot to gain a better overview over the data that are available on spatial scales. And what was super special there was they had this survey data dating back from the 19th century, the census data where the whole middle, central part and western part of the US were assessed by surveyors who listed trees and the landscape characteristics in order to assess the land for sale to European settlers or to settlers in the eastern part of the US. And these so-called pre-settlement data are raster-based landscape information that are digitized now or were digitized at the moment. It's 20 years ago. And then we could do some analysis and some modeling, and that was really very intriguing.
So you had this really long-term picture of how the landscape changed through human activities, but also other drivers as well?
Well, drivers, I mean, mostly it was sort of the climatic pattern at the time. I mean, there were humans, but we don't have any records. I mean, the indigenous population, we don't have any records of them, but we know that they were, especially in the southern part of Wisconsin, they shaped the landscape quite considerably.
Okay.
So it was very interesting to see sort of the original vegetation, at least original before major European or American settlers came to the land, and how it differed that was really a very strong experience. I think you could really dive into this past landscape.
And so it looks like you really investigated changes to vegetation. That was really the focal point while you were in the US.
Not necessarily changes, but just to quantify the past vegetation at the time and to explain the pattern. I also had a couple of papers related to complexity issues, so whether the pattern could also originate from a totally random point of view and sort of this type of analysis. But that was interesting, but it was just a side experience. So I was mostly looking into the vegetation, how it was back then, and then, of course, compare it to current day situations. And so what was very interesting also to talk to managers who try to keep in sort of reserves or areas that should be kept as natural as possible. And fire was a big driver there too.
Yes.
Sort of the forest fires that, especially in the south of Wisconsin, were shaping these open, wooded, well, sort of savanna type landscapes.
I mean, from the limited knowledge I have of ecology, forest fires, in a way, if one of these ecosystems burns down, it's actually part of a natural cycle. Yes. As part of restoring the ecosystem and regrowing it into a new state, an adaptive state, right? But I guess we perceive that as, disasters we have to prevent. What's your opinion on that kind of view? Because it seems to be two very juxtaposed approaches.
Yes, but I mean, I've never worked on forest fires really, but in the west of the States, Monica Turner and her group were really assessing these forest fires and try to explain why they happen and sort of the accumulation of the fuel and things like that. But I mean, mostly in California, for example, the management is not well done. They let people just build their housing in forests, and that shouldn't happen. And at some point, of course, increasingly with climate change, this can be disastrous from the human point of view, but from the ecological point of view, it's very clear and very predictable that this will happen. So we have to accept that in Mediterranean systems, this is just part of it.
And I guess that's the thing. We have to accept that it's a natural progression. But I think it also reflects the fact that we don't maybe consider ecology and ecological processes enough in the way we plan for the future. We plan to adapt for climate change. I mean, this is quite prevalent in one of the studies that you're really active in now, which is around light pollution. But in order to get there, you had to come back to Switzerland. What made you decide to then come back to Switzerland after being you were 3 years in the US?
3 years, yeah. Well, it was a very intense period, and I just started missing the Swiss lifestyle, especially related to climate. I mean, Wisconsin, you get very hot and super humid summers, so you always try to not touch your clothes from the inside. But it's really cold in winter, and so cold with a constant wind from the north that you can't really protect yourself. And I just noticed in Switzerland you can go out any time of the year. Maybe you put more clothes on or less, but it's just, you find a spot in Switzerland where it's nice, where you can actually walk and do what you want in the outdoors. Whereas in the States, I felt a bit imprisoned in the house. You need air conditioning and things like that. I just felt a bit imprisoned.
Yeah.
And also the car. I mean, I like driving, but it's, you have the car for everything. And that didn't match up in the long term. And also, again, a matter of opportunity, I got another project. It just happened to be funded at the right time, and I was asked to take that on. And so the decision was easy.
And also Wisconsin was very flat, as you said, and I guess you preferred the mountainous regions of Switzerland.
Yeah, it makes just your orientation in the landscape much easier if you have some elevation to look at.
I mean, I live in a pretty flat village. I see the mountains from a distance, but I think you live among the hills because the Swiss Federal Institute of Forest, Snow and Landscape Research, that's a mouthful. I'm just going to call it WSL because that is the short form, because WSL is located among the hills.
Yes, but that's now very small scale thinking. But, I just appreciated the Swiss climate.
Yeah. Well, you taught me broader scale thinking, which I'm still trying to apply to my everyday work. And I appreciate that too, because it's been quite fascinating to delve into territorial thinking. But we digress. But it's good to have you back. And in a way that also shifted you from vegetation back to animals, really, or into animals.
Yes. Well, what did I do when I came back? The project was more on forest modeling, which didn't really catch on very well with my interests. But as I said, it was an opportunity to come back. And the project after that was a European project, and that was more into my specialization. So it was more a land change assessment and developing future scenarios of land change in Switzerland. And we could publish that in 2007. And I think it was the first for Switzerland. So finally, not only climate change scenarios, but also land change scenarios, which are basic if we want to find solutions, for example, for biodiversity assessment. We also need to know how things might change in the future as a function of human land use.
And human activities in general.
Yes.
I guess I've been very focused on cities. So my perception of that is looking at how land use within a city or zoning will change over time and changes to density and population. But when we think of biodiversity, so broader scale thinking once again, there's a lot more involved. There's the agricultural activities. I mean, if we look at some of the recent reports on biodiversity, the Convention on Biological Diversity sort of said that agricultural expansion actually accounts for 70% of the projected loss of terrestrial biodiversity. And we'll put a link in the show notes. There's a nice summary of the various stats from the UN, from the different sources. But it actually spans much larger areas of land than cities do.
Mm-hmm. Well, what I noticed when I came back, I mean, this is now 15 years ago that we did this study, that cities were just blobs. They were blocks of pixels, very undifferentiated. And today, of course, we have better remote sensing methods to disentangle the green parts and the not so green parts and the super impervious parts. But at the time, it was just blobs. And I noticed that we need more integral landscape thinking, that, for example, also the monitoring data that we used for the study, they rely on non-city areas like agricultural fields or forests. And nobody did any surveys in the city. And I think nobody does it at the moment either. But at least we should look at cities as a more permeable structure than just blobs of pixels that are solid. And that led me then towards the more urban or human-dominated area investigations of biological patterns and processes.
And in a way, that has led to the three pillars that has been your research impact. The first one you sort of already talked a bit about, which is that land use change aspect. The second one, which I'd like to get into now, which I think is just fascinating for me because it's completely new to me, is the impact of light on biodiversity. And then the third and final one, in a way, leads in from that light aspect, is the connectivity, and that the city shouldn't be looked at just a blob or giant wall, but really more as some form of permeable sponge, call it that, that can help promote biodiversity. But I guess in terms of light, moving on to that, ALAN, brilliant abbreviation. I read that and I thought it's a way to remember the topic itself. ALAN stands for Artificial Light at Night. You looked into that because there is a certain effect on light pollution. As a human, I would prefer to sleep in, a dark room, not too much light, because otherwise, your sleep gets disturbed. There's medical evidence that shows that as well, that the lighting has a strong effect on us. But you looked at it in terms of animals. How did you get to that particular topic?
Well, it was by chance. I read in Zürcher Umweltpraxis, that's super grey literature. It's a little leaflet that comes out every couple of months from the more conservation-oriented area. And I read that they do some street light dimming in Urdorf and in Regensdorf. These are two suburbs of Zurich, sort of 1 kilometer long, where they take down the light level if there is no traffic and they move it up if there is traffic. So these are motion sensors and radar detectors associated with driving the light level.
So smart lights.
Smart lights, yes. And I contacted the author because I said, they just asked a couple of people, what did they think about it? And they liked that it's darker. So the people living close by these test light stretches. And I was thinking, wow, people don't interest me, but what about biodiversity? This is a fantastic mitigation strategy to reduce light pollution. And at the time, I wasn't working with light, but I just saw that and I felt like this has to be explored. And I started contacting the authors and they led me further. And then I ended up with a very inspiring person working at the electrical company of Zurich, Jörg Haller, who was just taking on my requests. And with basically no money, I had some leftover money for an intern. We started off a pilot project and mounted insect traps to these lights and tried to find out whether the dimmed situation attracts less insects, because light attracts insects because insects are orientating themselves as a function of the stars and the moon. But if humans now take down the moon and the stars to the world here, to the landscapes, then they lose their orientation potential and they try to change the angle constantly. That makes this sort of spiral movement and they get trapped in the light cone.
Is this why I always see insects just constantly hovering around my lamp at home?
Yes.
And I try to get it to move away and it just comes back?
No, they get trapped because the distance to the light source is much too close and they try to adjust the angle constantly. This is behavior that is, of course, genetically determined, but they get trapped. And whereas they were burning previously with HPS lamps, for example, LEDs are now cold, so they don't burn anymore, but still they fly around this lamp until they die of exhaustion. They forget to mate. They forget to eat. It's just a deadly trap still.
Wow. So complete disorienting behavior or disorienting effect on insects.
Yeah, that has been known before. And since I saw that this dimming could reduce the light level, this may actually not attract that much the insect, or it may even release it.
Okay.
I don't know about this. We haven't investigated. But we've seen with the investigations we did in Urdorf and Regensdorf that dimming actually attracts 30% less insects than undimmed situations. And that's, of course, a great success. And also now that we progress with these investigations on light pollution together with your color, we see more and more that dimming is a really decisive mitigation strategy to reduce impacts of light pollution on the immediate environment.
Now, it's incredibly fascinating how this little device, just to light a street lamp, can have such an adverse impact on a whole series of organisms.
And especially since lights along the street are, of course, more or less in a line, they may act as barriers. So really barriers in a landscape. And that has also shown a recent investigation that we are still working on, that the distribution of the light in the environment is also very important. So we experimentally modified a traditional street light LED so that it distributes the light into the environment, has a bigger visibility for insects and also humans in the environment. And that is a really strong driver of insect abundance too. So we see that the more light we distribute in the environment, the more insects are attracted from farther away also. So we advocate for not only dimming the lights, but also to have strongly focused the light on what needs to be illuminated. Of course, the best is always to switch off the light, right? That's what nature would like. But we can't do that, so we have to see that we really focus the light on things that people need, for example, stairways, that really the stairways are illuminated and not the whole trees surrounding them, so that people see that this is an obstacle, so be careful.
I guess it calls into question because, we need the lights for, as you also admit in your study, we need it for safety, whether it's navigating stairs or just to ensure that people feel safe walking at night. We need it to help cars see the roads during the night as well. But now we have this potentially conflicting aspect coming in, and we need to be able to balance our design of urban lighting to accommodate that.
Yes, that's what we're trying to do. So we have also a collaboration with the Swiss Institute of Metrology, with Peter Blattner and Kostis Borousis. And with them, they're physicists and lighting engineers, so really knowledgeable about this whole black box, which is a light. There is so much into this light, so much knowledge in LED light. We also have various dimming series, and we also have different light colors. And of course, we have to make sure that this is standardized, so the light that comes out of these lamps is the same amount, independent of the dimming and independent of the color of the lighthouse. I mean, LEDs can also have different colors, which is another mitigation potential. So we can have very neutral white, cooler color temperatures, but also rather warm, orangey, which is then more, for example, in the living room or so. That is more cozy. And this potential of LEDs to have different color is also something that we investigate, but we haven't really found any pattern yet. Literature claims that cooler LED colors are more attractive to insects, but we cannot really confirm this at the moment compared to the warmer colors. But we have to get more knowledge about this.
I suppose a cooler color might also reflect the starry night and the moon. At least when I look up myself, I tend to see those cool night sky colors.
I mean, that was also our hypothesis, because that's also what people find, that the cooler the color, the more insects there are, but we haven't found it.
Okay. What I found super interesting, and this study is published, and we'll put a link to the paper in the show notes, but it wasn't just about the insects. When you think about biodiversity and ecology, there's also the predator-prey relationship. And so you also looked at bats, which are very nocturnal animals, and they actually navigate using echolocation. So the idea of sound to help them navigate and sense the environment. For those also interested, we covered this with dolphins on the previous episode 4 with Sophia Boarino. So in a way, sound plays a bit of a role. But you looked at bats and how they then relate to the insects.
Yes, bats are also good indicators of land use. We mounted bat loggers together with Martin Obrist, also from WSL. He is a bat researcher. And what we found is that lights do attract bats that are frequent, for example, pipistrellus, and they seem to enjoy the insects at the lights because there's like a set table, so you can just chew up whatever's there, and that seems to please them. What we also see is that rarer species are not attracted by light. They do not even occur in the recordings. So, I mean, the study was in a settled area, and there we don't have any rarer species. So if we want to conclude further from the study, what we found is that the more light there is, the more we enhance the populations of frequent species like pipistrellus. And this could then lead to increased pressure on the rarer species, which then are pushed back even further. Yeah. So this is another hypothesis that originates from the hypothesis we had before, but that's how research works.
I guess, building on hypothesis after hypothesis and coming up with theories and hoping to prove them.
So artificial light has a landscape scale effect on populations and population interactions, certainly.
Just out of curiosity, how does a bat logger work, especially if you're in the dark? I guess it's based on sound?
Mm-hmm. Well, I don't know the technical details, but we have a microphone attached to a battery and some electronical components so you can program the device that it records from, say, 11 at night to 4 o'clock in the morning during 7 days, and then you have to exchange the battery and reload.
But it's detecting the bat's sound?
It's sound, yeah.
Okay, so not the wings flapping?
No. What you hear is the tick-tick moose pattern that they do when they are just patrolling. And you hear the tick-tick-tick-tick-tick-tick pattern when they are approaching prey. And then there is a little break when they swallow, and then they go on patrolling. Tick-tick-tick. And bat specialists like Martin Obrist, they have, of course, computer programs that analyze these sounds. And you can allocate this to individual species or species groups. So this is a science itself, to work with these millions of data records.
I must get a bat specialist on the show at some point. It's fascinating to see how they do it. And I think we can learn some techniques that might apply to many other aspects as well around biodiversity research. Yeah. Okay, but what I found interesting was that in this paper, a seemingly conflict/advantageous relationship was found between the lights, the insects, and the bats. And that, in fact, certain conditions favored more insects coming to the light, which benefited what you call medium-range echolocation bats. So those that they sort of travel a moderate distance, but they don't go far to find their food. So it almost like it helped them find their food and gave them an advantage.
Exactly. But unfortunately, this is the species that doesn't have any problems with humans anyway, or in human-dominated area. These mid-range echolocators, they're not threatened.
Okay, whereas the others remained in the forest.
Yes, the long and the short-term echolocators, they are more threatened, encompass more threatened species and species groups. So it's the way it is. Human impact is not good for all, that we know. But yes, if we find mitigation strategies that, for example, by darker nights, then of course pipistrellus has less advantages with feeding, but maybe the other species don't get pushed back that strongly.
Definitely. A very nice piece of work that I know you've also then delved much deeper into, you had a workshop with a range of experts around this idea of lighting in urban environments, and what you found that there's still a lot of challenges ahead for this kind of research. I think the most interesting one being that being multidisciplinary, everyone has a different way of measuring light and different units for measuring light.
Yes.
How do you manage that? How do you communicate that?
Well, we always do wrong and we know it, so we don't know what unit actually is relevant to measure light impact for insects or for bats. So we still rely on lux, the unit that is standardized and used mostly for human use. But in a future project, I will have a laboratory study, not a field study, but study in the lab, where we try to really have different spectral components, so different light spectral components, and try to find out which is really relevant to the species, and also how to measure this in detail. There is still a lot to do in terms of measuring light. Outside, especially, we have the 3D structure of light, and there are sensors, but they need to be tested and compared in order to find out which one is really the most robust and dominant one. So there is a lot to do still in terms of light pollution, and that's what I really like about the topic. So many areas in biology or ecology are over-researched during the years, but light pollution is really something that will give a new focus in the near future.
And I look forward to seeing where that heads.
And also the relative importance of light pollution, for example, to, let's say, managed agricultural areas. So what is the relative importance of light to other drivers of human-dominated landscapes? That will be a really interesting challenge.
No, definitely. And you already mentioned that these street lamps, in a way, represent a barrier. I guess when we think of the animals, and coming back to the movement aspect just now, that is just one element of a whole number of factors that urbanization has now caused in terms of barriers to connectivity. Mm-hmm. And we were able to collaborate on looking really more at the urban structure. And this is where you moved from bats and insects into frogs, which I thought was really fascinating and really enjoyable to just make jokes about frogs all the time. And so we then embarked also on this project. We managed to get some funding to then look at how urban areas, and in particular the use of green spaces, blue-green infrastructure, or nature-based solutions, or whatever you want to call them. We've had many guests give their opinions as well about terminology, but how these areas at different scales can impact biodiversity, can enhance it, and how we can contribute to it. What was your interest then in going into the green infrastructure space in regards to this?
Well, I previously mentioned that in my first modeling of land change, I noticed that cities are just blobs of impervious black or gray areas that are just distributed across the landscape. And from a personal point of view, I of course know that this is not true. So I was interested in getting more information on this structure of urban areas. And with the onset of remote sensing, which is really a strong driver of landscape research at the moment, we could assess the composition, the configuration, and also the 3D structure now with LiDAR. And that's a really great refinement. So cities are not as black and gray as they used to be nowadays. They are more colorful and also greener. Of course, it is more difficult to assess the quality of this green in cities because a green roof doesn't have the same quality as a meadow that has a humus layer of 0.5 meter. It's just very different. But at the same time, cities can, and this is also shown by studies, can advance biodiversity, so at least a number of species, by creating artificial habitat, which is not worse than any other habitat that is there more naturally. So humans can create habitats that actually increase the number of species. For example, flat roofs is one of them, or greening the facades is another.
Or having a little pond in your backyard.
Yes, that of course is already known, and it's always good to work with species that have a lobby in the population, in the human population, for example, birds or amphibians. People who like animals are more willing to do something good for them, and they also are more likely to have a regular monitoring, like amphibians or birds. So they're monitored regularly, and we know pretty well what the changes are, what the shortcomings are, and what should be done. And this data, of course, is super cool for modeling because it's spatially explicit. So you have raster-based data, or you have data that is at least distributed in space according to certain criteria. And that helps for modeling. So we can connect the points, for example, with connectivity modeling. And although the observations made during the monitoring are not done with respect to any connectivity assessment, it's just pure basic presence or absence of a species, you can still use them because assuming that a species is there where it is, there is something good about this place.
So you've highlighted a few key elements. On the one hand, there's the mapping. We start to understand now, and we have been doing a lot of mapping of potential new habitats, artificial habitats, or even natural ones in urban areas, as well as the broader landscape. I know there's also conventions, the Ramsar Convention or the Natura 2000 sites that you can start to detect on maps, and these are digitized, allowing you to then see what is the richness and concentration of these spaces across a landscape. Then you mentioned the observational data. We're starting to understand at least where these animals are, and we managed to delve into quite a lot of this information on frogs. How are they collected? Do people just report them? Do they take photos when they see a frog on the road or something?
There are different monitorings, but they usually go to ponds. This is where amphibians are most visible, and they listen who's there and also count the numbers if possible.
So they eavesdrop on frog croaking?
They eavesdrop on frog, yeah, exactly. And it's very fascinating. For example, the tree frog, they are tiny and super loud, and it's really a magic concert. So
Really?
it's a nice job. But I mean, again, their species are recorded where they are most visible or hearable, and that's at ponds. That's when they're in the mating mood, and only males give acoustic signals. So we know nothing about females that are more secretive. But it's at least a measure that is reported in a standardized way every year or every couple of years, depending on the monitorings that are made. And so we know who's around and who is increasing or decreasing. We often don't know why, but that's then the big modeling challenge.
Which is that third element that you then brought
exactly.
in. So taking that and putting it into models.
So we can have different scenarios why the species composition has changed, or we can make projections into the future and see if land use changes in this and this direction. Where do we need stepping stones to connect already existing habitat, or where do things work already well? Where are the habitats connected well, or where is just a cold spot? Where do we need basically start from scratch?
And this brings into play two seemingly very different types of connectivity, the way we defined it. On the one hand, you have this structural connectivity, which I think relates a lot more to how the landscape's composed right now and whether it allows that movement. But on the other hand, there's the more difficult to assess functional connectivity, which is a lot more related to how the animal behaves and moves. How does a frog navigate a landscape? It doesn't have Google Maps, so...
No. I don't know. Well, maybe it's just sensing humidity.
Yeah.
But and that's a limitation of the modeling studies where we assume that the species knows where it goes. Likely the frog has, sensors for humidity or smell, I don't know. But oftentimes it just tries to get through, and if it doesn't work, if there is an impervious area, a wall, then it moves along the wall and tries to find a hole. So it's more a try and error thing, unless it gets squished on the road, right? That's the final error. But still, we assume in modeling that the species knows where the next best habitat is, but in reality, this will be rather a random walk. And this can be assessed, for example, by gluing tracking sensors to the frog, which has been done, but not very frequent because it's rather tedious.
Yeah, I guess to catch them and then...
To catch them and to have the tracking sensor really remain on the frog. But from these studies, we see that it's not a very guided movement, which we assume in our scenarios.
There's also been an evolution. As a modeler, I had the excitement of really looking at the changes in how we quantify and we model these things. It really began from this theory of island biogeography, that habitats really are these little islands plonked in the landscape. But that's been superseded with then more network or graph theoretical approaches where they look at the least cost path methods. But because we know that frogs probably don't use GPS and Google Maps, now there's circuit theory, which in a way represents the landscape like an electrical circuit. And like an electrical circuit, current is going to find its way through a map of resistance. And this, in a way, is what we try to then characterize the city as being, and green spaces as being less resistant.
Yes. And the beauty about these circuitscape approaches is that we have a movement potential surface and not just a single path, which in least cost path is a bit limiting sometimes, but in circuitscape or in a circuit approach, we can actually have the landscape movement pattern sort of unfolding in full.
I guess if for the listeners to visualize, it's not trying to find the shortest possible path, but imagine you had a point A and a point B and you just dropped 1,000 frogs in and you said, try and move from A to B. And what we get from the model in a way is a certain number of frogs are going to try and go in this direction, whereas others are going to take a different route.
I've never done that, but I know that from a study that we conducted to see how fast frogs settle new ponds is that they certainly do not go to the next closest pond, but they may as well choose and move like 15 kilometers easily if they want. And I think 15. It also depends. Yeah, it depends on the life stage. So young male are known to move no matter what it takes. Also in, for example, the more better investigated lynx or wolf studies show that young males, they just move no matter what it takes. They cross motorways how many times they want. If they want to move, they move. There are different triggers for movement, of course. If you just forage or if you try to find a new territory or if you try to find a mate. These are different types of movement that, of course, we can't take into account in the modeling, but which we should at least discuss.
Definitely. And so I guess this, in a way, this approach now gives us quantitative information to be able to understand not just where the habitats are, how diverse they are, but also the potential of maintaining that genetic diversity.
Yes. You mentioned before the structure versus the functional connectivity, and that's a big issue. So from a land use approach, we can only assess the structural connectivity, say if we know that a bird needs a certain highly structured forest type. We can say that this is potential habitat for this bird, but we don't know whether it actually finds any food there. So that's the structural connectivity. And the functional connectivity is when we really know the species is there, persists there during unlimited time, and also reproduces there. So these are two fundamental types of connectivity. Often we conclude from the structural connectivity on the functional connectivity, but we should use caution. We should always check whether the species is really there and persists.
And I guess with new remote sensing technologies, and I guess there's also cameras being mounted along streetscapes as well, and also forests to look for animals. We talked about some of the sound-based techniques for detecting animals. I guess we'll have richer data as the future progresses.
Yes, also with artificial intelligence, of course. There are now different efforts to also use robotics to look into tree holes, for example, to see who's there, or eDNA, environmental DNA attached to drones so that you can sample along a tree canopy, for example. So I think with increasing technological advances, there will be also better monitoring that can include functional aspects, which today we still lack.
The whole range of new techniques from the biological to machine learning or artificial intelligence to really remote sensing that we can then leverage.
Yeah, and also robotics.
And robotics, yes.
Having these gadgets move to areas where people don't go.
I just had to think of a robotic woodpecker. I hope they don't make those because they can be quite loud. But you said looking inside the trees, so I guess you need something to get in there.
Yes.
No, very cool. And I guess now we are trying to tackle that challenge of climate change. I mean, just some more stats. We're using 1.6 Earths to maintain our current way of life, which is obviously going to have an impact on something else, and in this case, the rest of the biosphere. It's from the UN Environment Programme that sort of reported on this. We have the Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services, who have been really advocating for improving and doing something against serious biodiversity loss. In fact, 75% of our Earth's surface has already been altered by humans. And we didn't even talk about the aquatic aspects, but that is also being affected quite a bit. And a lot of the food system is responsible for biodiversity loss, according to the IPBES as well. So we're going to be facing these rapid changes as well as this uncertain climate. We are developing techniques that allow us to better think about and assess what's happening in terms of the biosphere. Where do you think we're heading in the future, and what must be done to reach a good future?
Well, if I knew that. Certainly we have to get increased awareness that green is needed by humans too. That's probably where we have to start with, that we don't only care for biodiversity, because biodiversity is not a very strong argument for many people. It's mostly the economic aspect or the health aspect, but we can get interest into this by just taking the multiple ecosystem services that these green spaces in urban areas provide. It's better for the human health, but also for the environment to have more green spaces, cleaner air, less urban heat in summers, and also just more recreation, more nearby recreation.
Cultural services as well.
Cultural services, exactly. Or people meet people, sort of communication between different groups or different cultures. So that's where we probably have to start with. Other than that, I think it's really hard for a scientist always to wait multiple decades until politics takes up what we found out. Climate change is the best example. I mean, climate change has been known for 40 years at least. And now only this is taken up seriously by politics. So we should, as scientists, be involved more closely to this politic interface, or have people dealing with this specifically, so that these early warnings could be implemented into politics much, much earlier.
Yeah.
And of course, early warning now sounds threatening, but if we want to advocate financial incentives, it's always cheaper to not wait until the disaster has unfolded, but do precaution.
To be more proactive and precautionary.
Precaution, that's the word,
rather
yes.
than reactionary.
Exactly. Yes, and then do something when the disaster already struck.
Yeah.
So I think that's the economic side, which can also be stressed. And then, of course, we have the young generation. More incentives should be given to that, to transfer the knowledge of the older scientists to the younger scientists or to the broader public by getting engaged in community actions. For example, I personally am in the construction commission, the Baukommission in the community where I live. And I can directly feed my research experience on the light, but also on the green space or the connectivity topics into the very, very local but still important agencies.
Personally, also, I'm trying to promote this biodiversity message. In my case, it's working together with architects who are actually embracing this idea that humans are not the only animal on the earth. And for listeners interested in how we've tried to implement this in Bern, you can listen back to episode 2 with my guest Scott Lloyd, where we talked about what cohabitation means and how actually what we've discussed, this whole analysis, for them represents a certain dynamism. It's trying to then show a dynamic process in what otherwise are static maps that they're often used to using. So I think a lot of different ways we can influence, and it'll be interesting to see where the future heads.
Yes, sometimes I'm very frustrated, but I'm generally confident that with a better communication, we could really achieve more.
No, definitely. Janine, this has been really interesting covering all these different topics, and hopefully we've been able to also paint a picture of the complexity of biodiversity and what's really behind it. And like I said, we didn't even cover the aquatic aspects, which I guess is a whole episode on its own that I know we certainly have someone we know who's worked in that space as well. But I'd love to get on to some questions that I ask all my guests so they can learn a lot more about you as well, about who you are and, in a way, what got you here. And that really starts with what inspires you to do what you do. How did you get into this topic in the first place? You mentioned you went into biology, but what really wakes you up every morning and gets you excited?
Well, I think what makes me really excited every morning is to know that there is a new day where I can add something to the mosaic of knowledge that probably, hopefully, helps to make a better society. During my professional career, I met several people who really inspired me. They were very enthusiastic. They started off with my biology teacher in school. At that point, it was the forest dieback due to acid rain that really troubled all of us. And that was probably the key experience, to know that there are ways to improve a bad situation, to make it better for the environment. And that triggered my interest in the biological sciences.
Okay.
And then during my studies, Christian Körner, with whom I did my master thesis, he was so fascinated and a great teacher, continuously throughout the years on the biology, on the processes leading to the patterns, and especially for alpine environments. And then my PhD supervisor, Felix Kiernast, who got me hooked up with GIS, the spatial modeling, and now more recently, Jörg Haller, who got me and supports me into this light pollution topic. So the inspiration comes from different people, but also from very interdisciplinary research, because I think personally that's where the innovation is. Sort of the grass is greener across the hedge, right? So that's what inspires me and what drives me to make a better and hopefully better scientific environment, but also relevant for society.
Yeah, and it's nice to also see how you've been passing on that inspiration to the younger generation through some of the students that have done their research under you. Also myself, I think I wouldn't have learned this much about biodiversity and ecology if it weren't for us meeting and collaborating. You're making symbols, are you making random hand signs here? No, it's true, it's true.
Yeah. Okay.
Yeah. Apart from the key people you've mentioned already, was there any other key moment or book you read or an event that you attended that completely changed the course of your career and mindset, other than the acid rain issue that you've also highlighted?
Well, not really by reading. Honestly, I've read so much, but it was more the inspiration from people. I mean, just talking to people, getting to know a lot of people, also you guys from EAWAG, that opens new perspectives. So I think collaboration, interdisciplinarity, this is really key in getting me or hopefully also other people going. Unfortunately, not by reading.
Yeah. Well, I guess we have enough papers to read on a daily basis that at some point all the information sort of funnels into one.
It's always digested already when you read something, but when you talk to people, it's not digested, and it opens up a lot of new possibilities. And so
it gives you interesting questions to ask as a result.
Yes, or unexpected insights, things like that.
True.
Yeah, so.
I do remember those moments as well, learning about frogs. Actually, I've been constantly saying frogs throughout this episode, but actually we focused on more than just frogs. We looked at amphibians,
exactly,
of which frogs are just one part of it. So forgive me there if I maybe irritated you with just saying frogs. Forgive me. What was one of the most challenging situations that you have ever faced in your career to date, and how did you overcome it?
Challenging was when I suddenly had a family. You have so many demands that are related to time, and then sometimes I get a bit lost, Family, kids come first, and then science, and sometimes science is not so plannable and predictable. So this is really challenging. The time budget, and also related to that, the energy budget. So sometimes I'm just exhausted. I mean, now my daughter is 16 and everything's fine. She's basically doing many things on her own. But when she was younger, that was really a challenge.
Being able to manage your time between the family and between, I guess, the professional careers, that's always not an easy task. And I guess in terms of time management, like what tips can you offer from your experience?
Well, first of all, be just human to yourself. Trust yourself. Listen to yourself and just be honest to yourself and see what's possible. And be also open in communicating that. I mean, with family, things don't go smoothly all the time. And then you have just to be honest about this. And that was for me the best to do, so that people knew what's up or not up.
Yeah, I guess being out and open, honest and just direct.
Yes. But also honest to yourself and try to get some time to yourself, although this is probably the most difficult task because there are so many demands on a family and a job and whatnot. So, but there are ways to do it and also just communicate good enough.
Yeah. How do you find time to yourself? What do you do when you want to get time to yourself?
What do I do? Well, it may be a bit simple-minded, but I really like gardening. I like digging in the earth. That sort of ground truthes me and it just relaxes me somehow. I like to grow fruit trees and vegetables, and I just like to see this grow, and also what's crawling around these vegetables, the insects and even the slugs. They don't make me happy, but they just are part of the system. And that just gives me a deep satisfaction to sort of grow something and dig around.
I used to grow herbs when I set up a herb garden in 2020, and I really benefited from that. And it was quite fun. So I can feel the peace you get from undertaking the activity. Although, as I've already mentioned in episode 10, I'm terrible at taking care of houseplants, or just generally. Do you have any tips for me and how I can improve it?
Regularly water the plant.
Oh, yeah.
That helps always.
I certainly learned that with basil. It drinks a lot.
Yes, and give them a big enough pot. I mean, normally the herbs you buy from the shop, the pots are too small.
Okay.
They dry out too quickly.
Yeah. I do tend to repot them after I buy them.
What I like to do, or what I just do without even thinking, is I'm a bird person. So I always listen who's around. That has also a deep emotional impact on me. So, for example, the robin is putting me always in a festive mood because it's a melancholic sound and I really like it. It's also to be heard year round. And then the common swift, when the common swift arrives in May, I know it's summer now. And that just gives me, I can read the landscapes or the environment just by knowing which birds are around. So that also gives me a deep satisfaction and sort of relaxes me.
Oh, wow. Yeah, I mean, I have some of my favorite birds. I don't know if they'd give you a deep satisfaction because I do like the kookaburra, but its laugh is ridiculously loud. And the other one I think they call it the Asian warbler. I just love it because the sound it makes is so funny. I just can't help but laugh every time I hear it.
Well, I'm talking about European birds. But yeah.
I have yet to find a favorite in Europe. I guess the heron that we see along the riverbanks is a strong candidate.
Yeah, for you as an aquatic person, a heron would be a good choice.
Yeah, and it's graceful walk, looking for food.
Genau.
Although I did see it brutally murder a rat the other day, unfortunately. But I guess that's nature, as they call it. So if you had a magic wand and you could change one thing about the world as it currently is, what would you change and why?
Well, completely unrelated to biodiversity, I would just stop wars.
Yeah, I guess it's true.
That's not the answer you're expecting.
No, I did not expect that.
The magic wand. Well, I would want to have a huge research group with a lot of technical staff to support my research.
Yeah.
It's always so tedious. And the more we advance in our careers, it's more tedious to obtain grants, to realize your science. That always takes a long time, years, and that's sometimes a bit a pity that it always takes so long. So I would like to realize my research much faster. Yeah. And that I could do with a lot of employees working for me.
No, you do a very good job at supervising, mentoring, and really teaching researchers to work independently as well and deliver some impactful work. So I can see how that, it just allows you to do a lot more and touch this complex topic of biodiversity. Yeah. But on the topic of mentoring, what advice would you give to young researchers, young biologists, ecologists that want to move into this space?
Well, if they want to move into science, then I would say rethink that because jobs are scarce. And it can be rather tedious to find a job at an age when you maybe have a family already. And it's all very insecure. But if you're determined, then don't be afraid and just get what you want. Try to get it and really trust yourself that it's a good thing to do. Maybe find mentors, find inspiring people and collaborate. I think that's another advice I would give. If you're determined, try to find good partners to support your research.
Yeah, solid advice.
And also that helps share the workload or helps, buffer adverse things. If field experiments don't work, you always have backups or something like that. Yeah, and don't overwork. Don't do too much. Be honest to yourself.
Yeah.
Yeah, there are many people with burnouts. There are many people who give up, but just adjust what's realistic. And that will always be enough in the long term.
I've heard of this saying, trust yourself, but also trust the process.
Yeah.
No, solid advice. Where can people find you if they want to get in touch?
Where can they find me? At WSL.
Yeah. Are you on social media?
And I'm on the webpage. Social media, no. Not time for that. But yes, they can email me or call me even. Yeah.
Janine, this has been a lovely conversation to connect and really just reflect on what we've been researching on, but also some of the other topics that I haven't really delved into that you've been very busy on. And I've really enjoyed learning a lot more and also just hearing your insights about where we're heading. So like I do with every guest on the show, we'll put all the information in the show notes about what we've discussed. But famous last words, one last message for the listeners to take away from today.
First of all, thanks for having me here. It's been a great opportunity for me to think and rethink who I am and what I do and also why. And it made me really forget my daily academic machinery for a while. And it was very satisfying to be here. Thank you.
Thank you very much. And thank you to you listeners for tuning into this educational and entertaining conversation with Janine Bolliger. To better understand why the frog crossed the road with or without GPS, or for a library of assorted bird calls to use as your daily alarm clock, check out the show notes over at petermbach.com/podcast. If you enjoyed this show and are looking forward to more episodes, please do subscribe. Follow this podcast on Spotify, iHeartRadio, Apple Music, or wherever you are listening from to be notified of the latest release as soon as it becomes available. Leave a review or pass this on to your friends and family to spread the beautiful messages from our many great guests. If you are curious about me or my work in general, you can also check out my website or social media. Head to petermbach.com, my YouTube channel, Peter Marcus Bach, that's Marcus with a C, or follow me on Twitter at petermbach or Instagram at petermbach87. Thank you very much for all your support so far. If you have feedback or suggestions or just know someone who has an inspiring story to offer, please feel free to reach out to me on social media. The podcast intro and outro song is called Breaking Sweat by Balloon Planet. Stay tuned for our next episode and next guest to hear how they are tackling the grand challenges.